Hello guys, and welcome to today's video. You might be working on some arithmetic operators, or you're building some sort of logic, mathematical logic, and you need some plus or minus or multiplication or something mathematical. You're going to have to understand Python operators and how they work. In today's video, we're going to be covering Python operators and giving some practical examples. Stick around. And here we have a Jupyter notebook where we've opened up a Python project, which we've called Python operators. Okay, so the first one we're going to be talking about will be the regular arithmetic operators, okay, where we have the plus, minus, multiplication, and division. Of course, these are the most basic ones, okay? So if we're to just pick an example where we have x as maybe 3 and y as 5, we could just easily say z is equals to x plus y. So what is z supposed to be? 8. All right. So in the same way, we can choose to say z is equals to x minus y. What is z? Z will be minus 2. So we've shown an addition, we've shown a subtraction. Okay. So what about if you want to do multiplication? It's just the same way. You go hash with that, and then your z becomes what? 15. That is 3 multiplied by 5. Same way, you can just do a division. You can say x divided by y, and your z becomes what? 0.6. Of course, you know, if you say y divided by x, it's like saying 5 divided by 3. That would be the inverse, which would be 1.67 if you want to round it up. Okay, so the next we're going to be looking at here will be the assignment operators. Okay. In assignment operators, we can borrow an example from what we've already done. For example, you have this addition where we said x plus y, all right? Now, if we say, let me add another one here, we can choose to say x is equals to x plus maybe 3. So, okay, the value of x here is 3, yeah. The value of x is 3. So it's just like saying x is equal to 3 plus 3, okay? So the value of x here will be 3 plus 3. Logically will be 6, okay? Now, instead of writing x is equal to x plus 3, we can choose to write it in another way, which is x is plus equal to 3, okay? So what this is saying is x is equal to x plus 3. That's exactly what this is saying. So instead of saying writing all this, you can replace it. So writing all this, you can replace it and say just plus and equals to. Okay. Now the current value of x is 6. Okay. So x is equal to x plus 3, and x is 6. So it will be like saying 6 plus 3. So the current value of x now, if I run it, will be 9. Okay. 6 plus 3 will be 9. All right. So you can repeat the same process with your negative. It's just the same thing as saying, let's assume your current value of, let's declare a new variable maybe 9. You can say variable plus, no, we are doing negative now, negative, and then maybe 2. So what this is saying is variable is equal to variable minus 2, okay? And it's like saying 9 minus 2. So variable should be 7, okay? All right. And the same goes for all these other examples. Now, in arithmetic operators, the first example we're talking about, the first use case we're talking about, I did not actually mention the modulus and some other ones. There are a whole lot of them. But let's just demonstrate the modulus. The modulus is represented with this symbol. Okay, that's the modulus. Now, if you have, let me declare fresh variables, x as 2 and y as 5. Okay, now z, let us say z is equals to y modulus 2, no, y modulus x. What this is going to do is, it will say 5 divided by 2, remainder. So the modulus is the remainder from the division of these numbers of 2 numbers. So if we're going to run the modulus, you see that the 5 divided by 2 is 2 points, remainder 1. So the remainder 1 is the modulus, okay? Now, where is this important? Let's assume you're building some sort of application or whatever, and maybe you want to determine certain things like, okay, here you have x, okay, x is 2. Let's say y is 5. Let me just make it an input, okay? Y, let's say y is an input. So z is y modulus, okay? So you can choose to write an if statement here. If z equals to 0, print if it's equal to 0, then definitely this is an even number. Else, now you have to watch out for your indentations, very important. Else, just print input is an odd. It's an odd number. Okay, input is, let me just change this for some sort of, input is an even number, input is an odd number. Okay, makes sense, makes sense. What else? Everything okay? If, yep. Okay, so let's run this. Now I'm going to put an input, okay? I'm supplying y. The system already knows what x is, so I'm going to supply y because y is an input. So y is an input, okay? So I'm going to supply y here. Let's assume y is 5. So it's going to say 5 modulus 2. So of course, you know, 5 modulus 2, the remainder will be 1. Let me run it. Oh, so y came in as another format, so I have to make sure that y is an integer. Okay. That's very important. Okay, so when you run it, you see it gives you this is an odd number. So let me run it again and supply maybe 4. This input is an even number. Okay, so that's one use case of that. Now, the next we're going to be looking into comparison operators. Comparison operators, just like that. Now, these are the equals to, the not equal to, the greater than, the less than. The same way you know it is the same way it is here, okay? If you're dealing with the equals to, that would be this. Not equal to will be not equal to. Here we have a Python comparison operators where we have the equals to sign as the double equal to, like what you have here. And a basic example could be x equal to y. That's just to show that if x and y are equal to each other, okay? And there's not equal to, which is the exclamation with the equal to sign, showing that x is not equal to sign to y. So this is supposed to return a true value if they are not equal to, okay? And a false value if it is the other way around, okay? Now there's the greater than, and then there's the less than, then there's the greater than or equal to. That checks if, like, you have x equals to 3 and y is equals to 4. So, you know, if you say x is greater than or equals to, it will be actually false because x is less than y, okay? To illustrate this on our Jupyter notebook, let me declare these variables. X is equals to 3 and let y be equals to 4, okay? So x equals to y in this format as a comparison gives false because we all know that x and y are not equal to each other, okay? let's say x less than y. X is actually less than y, so this should give you a true value, okay? Y greater than or equals to x. This should give you a true value because 4 is greater than x. Okay, true value. Now let's look at Python bitwise operators. Now, Python bitwise operators, they work more in a binary format. Of course, if you're supplying values to these variables you're going to be declaring, you declare the variable as an integer, but the actual operation are done in binary, okay? So we're going to be illustrating with a simple example. Now, there are two examples we'll be looking at here. One is the and the other is the regular slash, okay? Now, there are several use cases for these bitwise operators. Now, you have the AND operator, which is a basic AND symbol, as you can see. And this one sets each value of the bits. It sets it to 1 if both of them are 1. For example, you want to add two numbers, and you have the two of them in binary formats. So it looks at the two that you're adding, and it checks to see if both of them are 1, sets each of them to 1, okay? Then the OR checks to see if one of the two is 1, set the answer to 1, okay? Then the XOR, set each bit to 1 if only one of the two bits is 1, all right? Then the NOT is basically invert all the bits, and then you have other examples. A basic use case is what we have on screen here, where you have 5, for example, being represented in binary form as 1, 0, 1. Then 2 represented in binary form as 1, 0. Now, it is written as 0, 1, 0 because I'm putting the extra 0, which is red, as an addition. So if you're referring to the AND operator, now what it checks to see is if both of them are 1, right? If this is 1 and this is 1, set the value to 1. But it is not, the both of them are not 1, so the value here has to be 0. The same thing here to check, here is 0, here is 1. So here will be 0 because the both of them are not 1. So in other words, everything has to be 1 for the value here to be 0. And that's why you're getting 0, 0, 0. And the corresponding integer there will be 0. So your answer will be 0, okay? Now here, you have 5 and you have 3. 5 in binary here is 1, 0, 1. 3 in binary is 1, 1. When you want to add them together, you add an extra 0 so that it can balance up when you are summing up. The extra 0 is the red 0 I added, okay? Now let's start adding up. There's 1 here and there's 1 here. You are using an AND, so it means you get 1 at the bottom here, okay? Here is 0, here is 1, so you have to have 0 because both of them have to be 1 before your answer will be 1. So here is 1, here is 0, so here has to be 0, okay? So your corresponding answer from everything will be 0, 0, 1. And if you transfer it to your integer, it is actually 1. Now back to our Jupyter notebook, where we have our previous examples that we want to illustrate. So if you remember, the previous example we showed just now was a case of 5 and 2, and we also showed a case of 5 and 3. So in that case, I'm just going to declare some variables. But before I declare, I'd just like to first note that you can convert your integer, your basic integer, into a binary number by using the format method, okay? So let's assume you want to convert 7 or maybe 2 to binary, okay? So you encapsulate it like this, and then you can run it. So this is what it looks like in binary, okay? So now let's declare just a set of numbers just as an example. So here I'm converting 0 to binary, I'm converting 1 to binary, 5, 2, 3, 7. Just some basic examples. Let me now add all of them into variables, and let me print all these variables, and let's see the answers we get. Okay, so for these different examples here, these are their representation in binary format. Okay. Okay, so just as an example, let us say A is equal to 2 and B is equal to 5. What will be so as you can see, we have just done a basic Python byte-wise operator where we used the AND. Okay, so what this is doing now is it's going to take this value of A, convert it into the binary. Okay, now the value of A is 2. So 2 in binary is 1, 0. And 5 in binary is 1, 0, 1. The same kind of addition that we displayed in the previous chart, and it's going to give the final answer as 0. If we're going to repeat the same 3 and we have 3 instead, you see that the value will be the same value of 1 that we got in our previous charts. The same way, we can do the same thing for the OR, for the slash. Instead of using this, we can use a slash. And you see, if your A is this, in this case, you're expected to get the same thing actually. If A is 3 and if A is 2, you're going to get the same thing because of likely to get the same thing as 7. So you see, you're getting 7, the same answer in both cases. Now, the reason why you're getting the same answer for both cases, just as you can see here in an OR operator, okay? So now remember a basic rule for the OR operator. It sets each bit to 1 if 2 of the bits, no, if 1 of the 2 bits is 1, it sets it to 1, okay? Now, the binary value of 5 here is 1, 0, 1. The binary value of 2 is 1, 0. But of course, you add an extra red 0 here, the 0 here, just to complete it. Then you can perform the comparison. So for the OR, if you have 1 here, or you have 1 here, or you have 1 in both places, set the answer to 1. So here you have 1, here you have a 1 here, so here will be 1, and here you have a 1 here, so here will be 1. So 1, 1, 1, and 1, 1, 1 in your binary is 7. I mean, back to your integer is 7. For the second example, where you have 5 and 3, okay? 5 is 1, 0, 1, 3 is 1, 1, but you add an extra 0, so you can have a balance. Then when you have 1 here, you have 1 here, you're comparing them now, you have 1 at the bottom. When you have 0 here and you have 0, you have 1 here, you have 1 at the bottom. When you have 1 here and you have 0 here, you have 1 at the bottom. And of course, you have 1, 1, 1 as your corresponding answer. When you translate that back into the integer, you get 7. So that's the simple reason why when you are doing it as a slash, when A is 2, you're going to get 7. And when A is 3, and you're doing it here, you're still going to get the same value of 7. The last we're going to be looking at for today's video is the Python membership operator. Okay. You have these two variables, X and Y, and here you have Z is equals to X. Of course, you know, if you look at the contents, you see that X and Y, actually, they seem to have the same items in them, but they are not the same as per the objects, okay? So X and Y might look like similar objects, but they are not the same similar objects, in as much as the content of them are the same, okay? Now, let us just run a basic test to see if X is Y. Now, let me run this first. Now, let me print something. X is No, x is z. Let me check if x is z. So you're getting the value of a true because we have declared z to be equal to x here. So at an object level, this is true. Okay. Now let us see something at an object level to see if x and y are the same. X, y. You see that at an object level, they are not the same. All right. Even though the contents is the same, but they are not actually the same. Okay. If you want to check it at content level, you might want to do something different. At content level, you have to use the regular equals to, okay, to check it at content level. But you see, at object level, you have to use this other one, okay? So that's it for today's video. I hope you enjoyed it. If you've not yet subscribed to this channel, please do subscribe. Tell us what you have as a challenge where we can work on with you. And like our content, this helps us to know that we're doing something that you appreciate. We're putting a lot of hard work into this, and we're just here to make sure that we're all carried along in whatever it is we're doing. Now, I want you to always come back to this channel and check the comment section because I might be updating the links with exercises where you can practice. And I'll see you in our next video. Bye-bye.